Hey everybody, welcome to this episode of Teach Me Something. This is super informal, but I'm Jeremy and this is my buddy John, and
Hey
we've
there.
decided to get together once in a while and just record us teaching each other something. There's a lot of things in John's head, some things in mine as well, and it's nice to get them out and get them down and get them on record and publish them so that anybody else in the world can benefit. So today, John, what are you going to be teaching us?
I'm going to be teaching us the fundamentals of modeling.
Modeling
And
as in like how to put on nice clothes and walk a stage and get your picture
no,
taken?
not that kind of
Oh,
modeling.
oh,
3D, thank you. 3D modeling. We're going to go over like kind of a little bit of the genesis of it, and then we're going to go over how it actually works in a 3D software, and then the different types of modeling that you can do. And we're going to just do a couple small examples of actual modeling and showing you how that works.
okay. Now, real quick for background for the audience, you have been in professional 3D graphics roles for quite a while. Modeling is not the extent of what you've done, right? A lot of animation and a lot of compositing and a lot of different things, but modeling is definitely a big part of it, right?
Correct. Everything you see that's in like a video game or a movie, any kind of object is modeled. And so that's a lot of things. And that takes a lot of people and a lot of work. And so, yeah, you need modelers. And it's a it's like, it's a fundamental thing that you need to know how to do in 3D. Anything we see, like I said, games, film, yeah, production design, and any kind of thing. Modeling is you have to model everything. Buildings are modeled, cars are modeled, everything that's made today in the world is modeled first. And so it is a fundamental skill that everybody should kind of wrap their heads around and understand what is actually going into it.
Got
So
it.
a long time ago, this guy, Ed Catmull, wanted to make a they were trying to make in like 1972. He wanted to make basically the first 3D object. He wanted to make this 3D object, and so he basically said, "Okay, we're going to make an object out of vertices and out of like they're like just locations in space, and then we're going to have like planes." So this is a location, here's a location, here's a location, and then this is going to make up that plane. And they wanted to translate this into the computer. And if this model was around today, it would be worth like millions and millions of dollars because this was the first 3D object that was ever made. And he eventually, you'll see here how they kind of do it. They measured with this machine, and every time they tracked this location in space, they see he's tapping on the mouse. So he tracked all those points, and so all the points on that hand go to all these locations. These lines are just connecting those locations. So those what we call those in 3D, these little locations in space are vertices or vertex. So yeah, vertices plural. But now the next step is to have the computer draw a face that's kind of connecting these vertices. So I'm going to kind of jump in here. So this is you see these four vertices? These four vertices make up a face. Most actual faces, when you actually boil it down, are actually triangles. Okay, so this face is actually a triangle if you actually looked at the real math of this. But just for visualization purposes and for a lot of things we do, we make a lot of faces of objects with four edges. So we got edge. Oops. We got four edges. One, two, three, four. And then obviously the triangle has three edges. But in actuality, this square over here, like I said, is actually just two triangles. Everything that you see is a ton of triangles. So let me show a better example of this. So anyhow, so eventually they did make this hand, and it's like an incredible thing. So then 10 years later, they ended up with like Tron and everything else. So here we are in Maya. This is an industry standard tool that you use to model and do animation and stuff. And we can go to the vertices here. And so you see that this cube has been made out of this is a face, these are all faces. And then these are obviously the edges. So you can select all these edges, and then you can also select by the vertices. So these are the vertices. So I can move these around and change these in space. And this is actually how most objects are made. So that's a simple cube. It makes sense, right? All of the edges and faces. And you can also, I did not select by face, but yes, you can move that as well. And sometimes, well, yeah, let me move on to this. So what we have here is a sphere, okay? Now this sphere is what we would call a very low resolution sphere. So obviously the more faces that we have, and the more edges and the more vertices that we have, the finer detail this sphere gets, right? So this one is low resolution, but from back here, low resolution actually works. You can't really tell where the edges are from back here, right? But you know, you get close up, and all of a sudden it falls apart. So if you really want to get close up, now we're getting into really higher resolution, and a lot of stuff doesn't make it to this level. A lot of things you don't want to get too much higher than that, except when you're sculpting stuff. When you're sculpting stuff, you want to get like to a crazy, you know, much higher than this. And let me show a little demo of that. So I can subdivide this, and I can say duplicate all, or basically like double the amount of edges and faces. And here I can even do like 4 times, you know.
Wow.
And if I do 4 times, you'll see this thing gets super dense.
So now where there was a square before, and there's now 16 squares.
Right. So now there's like 16 squares. And in fact, the software is struggling to even get this done. So this is a super dense calculation here. In fact, let me X-nay that, and I'll just do a 1. It's going to come back here, but you get the point. So the only time that you would need to make something this dense is if you wanted to sculpt it, and you actually wanted to use like all these sculpting tools to sculpt it. So let me see here. Oh, okay, so it finally made it. Okay, so this, now if I zoom in here, you can see how dense this is, yeah?
Yeah.
Now that's super dense, and each one of these, I can still go in and select all these vertices and stuff. I'm not going to do that because it will probably cause me some trouble. But we don't, like, it's very much like TV resolution. At a certain distance, you don't need it to be that good, right? So, however, when you're sculpting really fine detailed crevices and eyes, and you know, really, really high definition things like say some sort of I don't know, some sort of monster with scales and all kinds of things, then you need something to be really high resolution like this. But there are a lot of solutions to fix that later. Okay, so these are what we call polygons. And it just means, yeah, polygon is like, what is that? Multiple sided, gone. I don't know. I can't remember what polygon means, but
Lots of gons.
What is it?
Lots of gons.
Yeah, lots of gons. Yeah, I should know that. I should know the definition there. But this is like I said before, this is like a four-sided polygon, and these ones are all using four-sided, but then you have some triangles up here. So you can combine them, right? You can have four-sided and you can also have triangles. And like at the top of most spheres, this is the case. Most of the top of most spheres have little triangles and stuff. Like I was saying before, you see how this is all cubes.
Yeah.
This is the exact, or sorry, this is all four-sided. These are all four-sided.
Yeah.
But this one over here, this is actuality, what's actually happening behind the scenes. This looks exactly the same. There's no difference in visual, in the visuals there. And the same for this. This is exactly the same. But what's actually happening behind the scenes is that everything is made up of triangles. Okay? So, and the same for this. This is exactly the same. That makes sense?
Yep.
So this is polygon modeling. Polygons made up of, four-sided and three-sided, and you can even do five-sided, but it's not suggested. You can do a lot of sided, but they run into issues later. So you want to make everything, if you're a really good modeler these days, you want to make everything with polygons. And part of the reason for that is when I'm selecting and working in this application, if I want to select like this edge loop, I want to select this whole string of edges and I want to modify it and do stuff with it. Well, I can do that. But if I go to this one over here and I go to edge loop, it doesn't know, like, it doesn't understand that. Does it want me to go up? Does it want me to go this way? It doesn't really, the tools don't really understand how to do that. So modeling with triangles, I'm sure they could build tools and stuff, but modeling with triangles is just really cumbersome and it doesn't make as much sense. And there are a whole lot of reasons why you don't want to model with triangles as far as just visually and in the workflow. But like I said, it all does end up as triangles at the end of the day. When you submit this to a game engine, most game engines will immediately turn this, they will turn this. If you submit this to a game engine, immediately it will turn this it will turn it into that.
Got it.
But for working sake, we can, with this, we can select these edges and we can modify them and do a lot of fun tricks and things with them. So that is polygon modeling. There is another type of modeling. It's called NURBS modeling. Now, this is a very strange type of modeling, and it is actually one of the first types of modeling. And it's made specifically by see these curves here. You see these little curves. So these curves are actually just communicating like this curve that goes around and this curve that goes around and these curves. All these curves are talking to each other and they're telling this isn't a face. They're just telling the software where the limits are, where it needs to draw this plane, I guess, this bent plane. So if I show you the patches, it basically draws this patch. And so it takes like the corners of these curves and it decides, okay, I'm going to draw a patch. So it's making a four-sided patch here, but you could do that with,
So are the blue lines the things that actually exist? Like those are the things that are stored. Those are the definition of your shape, and it's just connecting all of those to each other to form a 3D.
Correct. So yeah. So the lines are the defining factors of this whole thing. There's nothing. Yeah, that's a good way to say it. The lines are. And here, let me show a simpler version of it. See, I'm grabbing this and doing stuff. Well, let me show a simpler version. So this is a curve, and you can see all the little points that make up the curve, right? You see this?
Yeah.
Does that make sense?
Yep.
So you can modify these little points, and in fact, I can modify them with a big brush here, and I can kind of move them all together with a little soft offset and stuff. So this is, we would, if we wanted to make a little boat, okay? So what you would do is you would select this curve and select this curve and then select this one. And you can see the shape of the boat, right?
Yeah.
And I made it kind of wonky because I want to show you what happens here. But now we can just go up, and instead of using polygon modeling, we can go up to this surfaces, and we want to connect those. And so it looks at all of those points. You see each one of these little lines. That actually isn't where those are. These are all equidistant, but it kind of makes up its own little paths there, and it creates the hull of this boat. But the only thing that is actually needing to be edited here is the curves. So we can go back in and grab this curve, and we can move this around. And
now, when you said I want to make a shape out of these three curves, how did it know in what order to connect those? Like first the left side of the hole, and then the bottom, and then the right.
So it knew based on my selection order.
Okay.
So you basically select, I selected this one, and then, or sorry, this one, and this one. So yeah, it just knew based on my selection order. And right now, like you can also flip, like right now, this part of the surface is the surface that we would see and that we would render. But if we wanted to show this is obviously black. Now, this is also the case with something like this. Let me show this. So all objects only have, like all of these faces, they have a thing called a normal, okay? And a normal is a perpendicular line that comes off of this. Let me show you here. Okay, so do you see this little green line?
Yeah.
Okay, now this is the face normal. And this is basically, this talks to the computer, and it tells the computer what direction this face is pointing at. Say what?
What direction this face is facing.
Yeah, what direction this face is facing. So the computer, this really helps, because if you didn't have this, well, why? Maybe it's this side, maybe it's facing this way. And so you need this normal. This is a little math thing that goes along with every single face. And this normal has to, like, if I bend this way, you can see that it'll go with it. And so this is very important for the software to know. Okay, so now what we can do is we can select these and we can switch the normals. So if I reverse these normals, now all of the faces are pointing inside, and this is what would render, and this is what we would see. Now these are all black because this is like, useless, and it won't look good if we render it. So it'll actually render black like that. So you can tell. But some programs by default, they will render both sides. So you'll have a double-sided, like it'll be double-sided on. And some programs do not do that. So that's very important. But yeah, the normal facing is a very key thing. And all of this, initially when you make objects, it usually understands which direction you want to go. But in case you need to switch it, then you can, let's see, I think, oh no, that's just doing the other. Yeah, that's doing the other. I also can complicate this by adding more spans, so I can make that a little bit more rounder. Now, in the computer world with NURBS, let's get back to NURBS here. Okay, so we had these three curves. Well, we can't do much with curves. We can animate them, we can kind of use them, but they are not as friendly to work with after this initial stage. So what you want to do is you actually want to turn this into a polygon mesh. So we have tools that actually convert from NURBS to a polygon. So let's see, NURBS to polygon. You can get this little checkbox here. And there's a whole bunch of ways to do it. Look, it says type, triangle, or quads. I'm going to go quads. And then I'm just going to go with like the default settings here. And so it made a very simple version of this. And oh, my little I see. Sorry, my I didn't center selection here. So see, it made these polygons, and it used all of the math and everything that we were doing, and it just made this out of polygons instead. So now we can actually adjust this and move this however we like, and actually be able to kind of mess around with it. Now, it still actually holds this history. So at least in Maya, and I believe this is the case in other programs. So if you did want to edit these curves, you still wanted to edit them, we could edit this and we could move this and see how it's obeying that history.
Very interesting, yeah.
So you can still mess around with this. And even though I've done things up here, I think I can, let's see, I think I can like extrude this here. I think this will work, and I think this will still obey the construction history here. Yeah, but it gets all funky. Yeah, and so this is actually a good point in modeling, in that I don't know the best way to show this, but every single one of these vertices, see these little guys? Every single one of these vertices upon creation gets a number. So this would be like 32, and this would be 33, and this would be 34. And when something's referencing it like this is, it locks in these numbers. And so as soon as I extruded this face out, and I as soon as I extrude and make new faces, it renumbers all of this. So this whole thing gets all new numbers. So anytime you modify the mesh, it gets like a totally renumbered thing. So that will actually break things like this. Okay, so that's getting a little too into the weeds, but I wanted to show you something like this. This is a very common thing that needs to be done, like pipes and roads and all kinds of things. And so what we can do is we can actually use curves in a combination with meshes. So this is just called a sweep mesh, and it's basically going to take a mesh, or it's going to take like a 5-sided. Well, you'll see here in a second. Let me just click on this. Okay, so essentially what this did is it took what does this start out with? I think it's like an 8-sided. It's eight edges. And it made 8 edges, and then it moved along the curve and made another 8 edges, and it moved along the curve and made another 8 edges, and then it connected all of them together.
Did you draw that 8-edge shape?
No, I didn't draw this 8-edge shape. This is a standard, like
okay.
So this just comes in Maya. It's a feature. It's like a feature for making things like this.
I see where it sides right there.
Yeah, so you see these profiles, we can use any of these. So this one, I can make it 4 sides. I can, make it, 20 or whatever I want.
Got it.
Here's a star, So this is a really nice feature that Maya has. And you can also, like here's a rectangle, and you can really do a lot with these, all these, you can rotate, you can twist it like this. There's a lot of fun stuff you can do here. And this is great for making braided hair, or I don't know, roads and pipes and lines and all kinds of things. You can also do your own custom shape, and that's kind of what I was talking about, how they did it. They're just taking this old custom way we used to do it, and this is actually anyhow. So this is a fun tool. This actually like rope, you can make rope with this, or all kinds of fun things.
So I've seen a kind of modeling where you're working with a cage, and that cage informs the shape within it. And so when you stretch that cage or change the shape of that cage, it influences the shape of the shape that it's controlling. What is that called? That's not exactly NURBS, is it?
No, that's not exactly NURBS. Okay, so NURBS are a smooth mathematical surface controlled by the curves and the control points.
NURBS always form surfaces.
Yeah, they form these surfaces, and all these little surfaces are, you can manage, you can do stuff with these little surfaces. But sorry, all these surfaces are controlled by the curves up here.
Yeah, yeah.
So whereas I can't like extrude out these surfaces. That's not how NURBS works.
Right,
Like
right.
how I extruded these up here,
Because you
I
first converted it to a polygon mesh.
right. I can do that with Polygon Mesh, but everything is tied to these three curves that I made.
Right, got it.
So this is how, and it's just math. It's this, what it's actually doing is saying, okay, this curve is up here and it needs to make it to here, and this one needs to make it to here, and it uses these lines that it draws on here as the math to figure out how to get from this curve to this curve to this
But
curve.
are you familiar with the kind of modeling that I'm talking about, where you work on a cage that influences?
100%.
Okay.
100%. So what happens in the 3D world is something like this. We You want to work as simply as possible, right?
Yeah.
So if I'm working on this, and let's just say I'm trying to make a head out of this, okay? And I've got my tools, and I'm trying to, let me see here. So I got my tools, and I'm trying to, make the shape of a head and do all this. I want to work in this simple way as much as possible. Okay. And I'm a little backwards here. Okay. So I'm saying I'm making like a little, so this is very simple, and it's a little too simple, but it'd be really nice if I could smooth this out, but retain this simplicity.
Okay.
So I like working at this level, but I want it to look smoother. Like I want these to be rounded out and have more definition.
So
So what
essentially
this
what you're saying is that for your modeling work that is actually manipulating it, you don't need the resolution that you would like to have for viewing the object.
uh well, no, I actually want this to look smoother, but
Right.
I want to control it with less. I want to
Yeah.
control it with a smaller amount of vertices.
Yeah. Yeah.
So this is where, and if you actually see in here, do you see this Maya Catmull-Clark?
Right.
Okay, Ed Catmull is the one who made that hand that I showed you.
Oh, wow. That's really fascinating.
Yeah, and so he made this subdivision control, which basically takes all of this and subdivides it, but it holds on to the the simple shape of it. And I can subdivide this. So this is 0, and then
Okay.
this is so let me turn on the
So 0 is true to the shape that you're manipulating.
right. Let's see, wireframe unshaded so you can see this. So 0 is the true to the shape, and then once I go to 1, then it's complicated it. It's basically doubled the amount
Yeah.
of like I showed you before. It doubled the amount like I was doing down here with that. And then
Yeah.
if I go to 2, now it's, well, I guess maybe that's tripled, or I don't know. Yeah,
Yeah.
I would think the first one doubles it, and then the second one triples
But you
it.
still have a simple cage for editing it.
Correct. So now if I go to select the vertices, all this is rounded out, but I still have my simple verts,
Yeah.
my simple shapes here. And
That's
so, yeah, so now I can actually modify all this and do things with it. And I'm getting a lot of control, instead of trying to do this with like this down here, because this, if I move, I can do it. Oh, I don't know if this will crash it actually. It shouldn't crash it. Yeah. So this is going to be pretty crazy. But like you can see this, I can really do a lot of defining stuff with this, you know?
Yeah.
I can really get into details here. And this one's not subdivided at all. However, then I run into a problem of how do I actually move this around and animate with it and do
Yeah.
things with it, right?
And
So
make a game out of it where it's
yeah, and
has to actually
make a
calculate
game.
everything.
Right, right, because this is like a really heavy calculation. And so yeah, I might have been able to make this shape, but I'm doing it at a really heavy cost. So this is a lot cheaper. And games typically don't actually have the Maya Catmull-Clark subdivision in them. You use this for characters in movies and films and things like that. When you want to work on a simple face of a character, you want to push and pull these points with controls on a character. It's okay though, because what I'm showing you here, this is what happens is we do need to sculpt stuff and make it really high resolution so that we can make something like a face. So this is a face that I'm working on and it's sculpted. And when you look at it, I mean, it's super dense. Look at that. Look at the density there.
Yeah.
I mean, it's pretty crazy. We're talking, you know, millions of little polygons there. But it allows for us to work in this sculpted way, and we can really push and pull all this, and we can really do some fun stuff like we can make, like, look at that, we can push and pull these points around and just do really interesting things with it.
Mm.
And define stuff. Now that looks terribly ugly, but yeah, let's say I wanted to carve out his jaw right here, so I can sculpt, and that's using millions of these little polygons,
Yeah.
And it's pushing and pulling those as I use these tools, which is really fascinating. Now it's going a little too far, but so the question is, how do we get from this really dense, this really dense version? Now, how do we take this dense version and bring it back? The process is called retopology. And so what you actually want to do is you want to take this really dense, can you see my screen here?
Yep.
Okay, so you want to take this really dense thing that you made, and you want to now draw simple polygons and make a simplified form of it. So this is actually a pretty cool software that you can use on your Mac or on your tablet, and it makes this process a little bit more fun, because this is an extremely grueling process of figuring out. It's like a puzzle. It's like, okay, how do I draw all these faces so that they will work? And the main thing you're doing actually is you're trying to recreate this so that it's actually able to use in animation. So if you see here in animation, you need all these polygons to be in a certain way. Like, see how these are all colored like this?
Yeah.
So the reason they're colored this way is so that when I grab like the corner of this mouth here and I pull it this way, all of these will react in the way that I'm expecting, in the way that I want. If I just had straight lines making up this thing and like a grid, it wouldn't perform well. These loops actually kind of follow the muscles of the mouth and how the mouth actually works in real life. Same with the eye. This pattern here that we see and that we create is based on how our eyes work and how they move around. And so we kind of base this off of reality. We use muscle flows and stuff like that to inform the mesh and to inform the rig on how to actually stretch and move these polygons and these edges and vertices around. it's laborious and it takes a long time.
John, let me ask you, what's the reason for creating so many polygons and sculpting and then using retopology to get back to something simpler? Why didn't you just create something simple in the first place?
Yeah, it's a good question. So it's actually quite hard to just sculpt this character and using these like you're just drawing points in space, you know? So
Okay.
let me show you. Like with well, let me get something
And why
that's
can't
actually,
the process of retopology just be math? It doesn't seem to me that it should have to be a manual process.
it seems like you could reverse the subdivision. Like you could take this subdivided mesh and then reverse it.
Yeah, or using some algorithm. I mean, you could also just kind of shrink wrap it, like make a simple wrapper and say shrink to fit my
Sure.
complex.
There are people that have written software and stuff that do that. But what you'll notice is like, say this character looks a lot different than this girl, right? They're quite a bit different. Look at her nose and how that all functions and stuff, and how that, how those lines go and all that.
Yeah.
That's going to be a completely different model than this character.
Mm-hmm.
This will be way different. So my ears are in different places, how I might draw these lines and where my mouth sits. This is an exaggerated guy,
Yeah.
So that's not going to work. What we actually do for video games, everything has to be as low poly as possible.
Mm-hmm.
So this process that we're doing here, you want to make this very much like this for video games. However, we can, you were asking why do you, yeah, I was going to show you how we just draw lines in space and how annoying that is. Okay, so let's get a plane. Actually, this is how most people do it. This is how you would do it back in the day. You would get a box, and I would just have a picture of this guy. I wouldn't have this guy here, right? I would just have a picture of this guy. And then I would have to subdivide this up, and I would probably do something like this, and this, and then I would start to try to sculpt a head out of this. And I would slowly try to figure out, okay, so the chin's like here, and this is like the neck, and then the head, the head's going to be like up over here, and this is the forehead, or sorry, the back of the head, I guess I was thinking. And then this would be like the forehead, and the eyes are here. And then this is maybe comes out like this. And there are guys that can do this. There are many guys that can do this. However, it doesn't feel as easy to change things and as quick to change things. When you're sculpting, you can kind of like really see what's going on. And this, we're like slowly building this and getting something going. And eventually, of course, we'll have like a product of a head, but, and I'm not doing a great job here. But you also only usually when you usually work on something like a head, you only work on one side of it. So you mirror the other side. So everything you do is mirrored, right? So that's the nice thing about modeling anything that's symmetrical. You only ever do like half of it.
Yeah.
But anyhow, so this is the process of making this head, and we're slowly like building upon it. And yeah, I'm not going to model a whole head here, but you see how this, it has its problems, because I have to like even I'm working with these squares and stuff. I need to actually get to the point where I'm getting all these nice edge loops. I'm building all of this in.
Yeah.
This is kind of hard to do. It's easier to sculpt it and then build all these edge loops in after the fact. Does that make sense?
Yep.
So all of these edge loops and things are actually so that we can rig the character and move them around later if we didn't have to do that, you're right. This way, maybe it's not that bad or easier or whatever. But this is the way. For a face like this will do just fine in a game with just these polygons showing like this, right? We talked about that. However, once we get when we actually do like film level work, let me see if I can open something here real quick for you. Okay, so you're going to see here, this is a actual film level character, okay? This is a film quality character, and you see how few things we're dealing with here?
Right.
We got very few pieces going on here. However, we got very few polygons and vertices and stuff. And the reason for that is the more of these that you make, the more you have to manage when you're actually creating all of these controls to move this character around and to do things with. So you've got to manage all of these little dots, and it becomes a lot to manage. I mean, look at this. This is just, you're just managing like these ones over here for this row of vertices. And let's see, this guy. This guy is, it's managing this one, these ones. So everything that's moving right now, you've got to manage all that. And if you make it super high resolution, it is way too much to manage. So when you're building an actual rig that's good, you want to build it at a lower resolution like this. And then this is where in film and in that quality, you can get into the smooth, like the subdivision level. Okay. So this is where you would like basically increase the subdivision level, and you would get these really nice smooth shapes.
When you're rendering?
Yeah, normally you don't turn this on until you render, but if you're really trying to get like, this mouth shape to look right and you want to double check, you can go and turn this on in the viewport.
Okay.
And I'm actually forgetting where it is on this character right now, but they have a control that basically turns on all the smoothness. And so then you can actually see and make sure that the eye, because once this gets subdivided, it actually makes, instead of these jagged lines, it subdivides and it makes a really nice smooth arc here for the eye.
Yeah.
So this is film level stuff. You don't do this with game level. At game level, you keep games at this, probably this, or a little bit, probably double this would be the most for games. And you do have to manage all those curves.
What about software? If we've got folks that are watching that are thinking about the basics of 3D, and they're thinking about trying stuff out here, you're showing stuff in Maya, but that's a professional software. I think a lot of people know about Blender, right? That's a new one.
Yeah, and this is Blender, and it's amazing, like for sculpting and it's amazing for everything. You can do everything I'm doing in Maya in here. All those tools are all the same. You have all your objects. I can make I can make a circle, or
so a person shouldn't really feel like they're limited if they don't have Maya. They can go pretty far with
no, this concept, what I'm teaching here, is a fundamental concept in every single software. It's the same in Cinema 4D. It's the same in every, what we call a content creation package. Every content creation package has these fundamental rules in it.
However, there's also these different kinds of 3D design, because I, for instance, work with a lot of mechanical. I use Fusion, and I make a lot of mechanical things out of solids. And so a program like this wouldn't be the right tool for me.
Right. And so in the world, we call this, there are organic objects like humans. In fact, you would use ZBrush or something even more complicated to actually create better organic objects like this character. And then you would bring that really dense mesh into Maya or something else to simplify it. But like in Blender, you can actually sculpt pretty detailed, like I'm doing here. And you can do all of that in Blender. Blender is amazing in that way. And you can sculpt all of this, and then you can actually retopo in here, and then you can rig it, and you can do everything. So this would be like on the organic side. Organic would be trees, animals, humans, this kind of stuff. But then there is another side called hard surface modeling. This would be like a radio, a car, any kind of like device, like technology device that you would see. So for that, there are separate programs. You can still do it in Maya or in Blender. You can do a lot of hard surface modeling, but there's artist level hard surface modeling, and then there is like technically accurate and production level hard surface modeling. So the software that you would use, like the software they use to make cars, or the software they use to make all of the objects, most of the objects you see in stores, are really high-end software that you can use, that you can print off of, and it's very accurate. What's the one you use? It's called Fusion 360.
Yeah. Fusion.
Oh, Fusion. Sorry. And Fusion is a hard surface modeler, and it uses NURBS, and a lot of them use NURBS actually. And that's kind of how you. I was going to try to show some examples of people just kind of going through and making stuff. But you can do it just with Polygon modeling, or you can use something like Fusion where you're really getting like the accurate.
One of the things that I found was interesting is if what you're making is, let's say, a little manifold like that, like that right there.
Yeah.
If what you're making is that, it's described by an engineer, it's described by math and equations and so on and so forth. And when you define that in software that is made for that, and you're using solids, then for instance, when you want to do something like fillet a corner, fillet an edge all the way around it, it's very easy for the software to do that. And if you have a complex intersection of two shapes, and you want to take that joint and fillet that, it's apparently very easy for the solid modeling software to do that math. But if it's a mesh, it becomes very, very difficult because that shape has not been mathematically described. It's just a mesh. It's just a bunch of polygons. It gets very difficult for the software to figure out, how do I do what this user is asking me to do?
Correct. So that's where you've really got to figure out like what kind of thing you're building and what the best tool is. And so there's been so many different tools made over the years. So there's a lot of different ways to do things, even with polygons. In the way that we just saw with that other one, it's far more accurate, and it's actually doing something based on math. This is just all kind of guesswork, like all of this is just guesswork. It's like, there's nothing mathematical about any of.
It's kind of like when I talk to students about Fusion, and I talk about the difference between, in Fusion we have a curve and we have a arc. And I tell them that a curve is what you use when you are drawing an artistic shape, a shape that you're creating as an artist. Like, hey, I just want this shape to look like this. It's the edge of a guitar, or it's the edge of a plant or something like that. So I use a curve, versus an arc is what you would use if you were designing a manifold or something. You would have an arc that was described by a radius that then transitioned into another arc with the opposite radius, and everything's defined by math even as you design it. And I always say it's really those two different roles, the role of an artist and the role of an engineer. And most of the tooling that you've shown us here so far is tooling for an artist.
Yeah, and even so, Plasticity is actually a tool made for it's made for artists, but it's actually accurate and good enough for designers as well, who are actually going to create real world products and real world things. It's a very nice hybrid for that.
Yeah, it is. I really like this software. The only reason why I don't consider it more strongly is because Plasticity is not parametric. Parametric keeps track of all of the changes made all throughout the history of
Right.
the design, and
Yeah.
Plasticity doesn't do that.
Yeah. And this is a, you know, a much cheaper software than
It's
than
good though. Really good.
Fusion. But
Can you
you know,
can you bring up Shaper 3D real quick?
Sure.
That's one of my favorites as well. It is parametric, and it's a bit cheaper than some of the first class ones, and you can do it on the iPad. A lot of people do their design on the iPad.
Oh, that's cool. Yeah.
Yeah, but it's good software too. Really good UI. I really like it a lot.
This one looks really cool though. I do like the parametric aspect of some of these, and some of these functions, like this array function where they're arraying the spheres, and then they have a really good Boolean function. Boolean is like where you're just taking one object and cutting it out with another object.
Yeah.
Yeah, and then look at that. That's cool to make a golf ball that fast. I mean, that's incredible.
Yeah, that's neat.
Yeah.
Okay, well, John, let's go ahead and wrap it up here. Thanks for sharing all your knowledge. That's really cool. I hope this is of value to some people.
Yeah, I hope it is too. Yeah, if you have any questions, just hit us up.
Okay, and I think I am going to publish this. So if you're watching, you're probably watching this on YouTube. There's probably a channel down below, and I would invite you to go ahead and prompt us in there for any technology, 3D stuff. You'll get to know John and I and what kinds of things we like to talk about, and prompt us for what kinds of topics you'd like us to teach each other and you at the same time.
Yeah, thank you guys for listening. And yeah, if you have any questions, feel free to hit us up.